In this video, we are going to see problem D, make a palindrome of recent Codeforces Round 1036. So let's read the problem statement. You are given an array of size n and an integer k. You may perform the following operation any number of times. Select two integers l and r such that r minus l plus 1 is greater than equals to k. This statement means that we can choose any window of size greater than equals to k in our array. Then select an index I such that I is in the range L to R where AI is the kth smallest number out of the subarray. Okay. If there are multiple possible values of I, you may select any. For example, we have this array and if we choose L equals to 1, R equals to 5, that is the whole array 1, 2, 3, 4, 5, and K equals to 3. The kth smallest number in our array would be 2, because the first smallest number would be this one, second smallest number would be this one, and the third smallest number would be this or this 2. So we have two choices, that is indices 2 or 3 as our possible candidates. Then delete AI from A, concatenating the remaining part of the array. Okay, so we'll remove either one of these two and concatenate the remaining part of the array. Determine if it's possible to get an array that is palindrome after any number of operations. Note that the empty array is considered a palindrome. Okay, so let's see with an example what this problem is trying to say. Let us suppose we have array 1, 2, 2, 1, 3 and k equals to 3. We can choose any subarray of length greater than equals to 3. Let's say we choose this subarray and we remove the kth smallest number from the array. Here k equals to 3, so kth smallest number would be first smallest number would be this or this, second would be this, and the third would be either this or this. So we can remove either this or this. Let's say we remove this. Then after concatenating, we would have our array as 1, 2, 1, 3. Now, this we need to make sure becomes a palindrome. An array is palindrome if for every ith index, the n minus ith index and the ith index have the same value. Here we can see that this is not a palindromic array because the property of palindrome is not being fulfilled here. Can we make this palindrome by performing some more number of operations? Let's see. What if I choose my subarray as this and try to remove kth smallest number in this array? What would be the kth smallest number? The first would be this, the second would be this, and the third would be this. So I remove this 3 and my new array would be 1, 2, 1. Is it a palindrome array? Yes, it's a palindrome array, so we'll print yes. So we can convert our whole array 1, 2, 2, 1, 3 into a palindromic array by performing some number of operations. Let's see how we can solve this problem. To solve this problem, I use 3 steps. First step would be removing useless data. Second step would be to derive a simple problem from our current problem. And third step would be to solve the simpler problem. Okay, so let's see what we mean by removing useless data. Let us say we have our array as 2, 3, 1, 5, 2, 4, 1, 2, and let's say our k value is 3. Now, let's consider whole array. What will be our kth smallest integer? Our first smallest integer would be this, the second smallest number would be this, and the k equals to 3 smallest integer could be this, this, or this. We have choices. So, let me ask you one thing. Is it possible to perform any number of operations and remove ones from our array? The answer is no, because since we can remove only the kth smallest integer, the numbers smaller than the kth smallest integer would never be deleted. So first thing first, the Numbers smaller than the kth smallest number would always be present in our array. So these would always have to be present, and this should become palindromic at the end of our whole operations. Okay, now let's talk about the numbers that are greater than our kth smallest number. That would be 3, 5, and 4. Now, is there any contribution of 3, 5, 4 in our palindromic array? Will there be any contribution? Let's say at the end we reach a point where our answer is, let's say, x, y, z, y, x. This is a valid answer. And let's say this was made using ones and twos, and 3, 5, 4 are the numbers that are greater than the kth largest element. So let's say in our answer we try to incorporate 3. Let's say we had a 3. To have this 3, now this 3 just ruined our palindromic array. Now it's not palindromic because it's matching with this x, and our answer got disturbed. To have this 3 make palindromic array, we would also need a 3 here. So does the presence of 3 made any changes, made any contribution to our palindromic array? Did it make anything helpful? No, it did not. It just increased the length of our palindromic array. Let's say this 354 was present here. Let's say 5 was present here. Now for this array to be palindromic, there should be a 5 here as well. So we can see that having numbers that are greater than the kth smallest number doesn't make any contribution to our palindromic array. So would it be helpful if we could just remove all the numbers that are greater than our kth smallest number? Yes. So we can just remove all the numbers that are greater than our kth smallest integer. Like we can just choose a 3 size window. Here we will remove 3. Again we can choose this window, the 5 would be removed. We can choose this window and 4 would be removed. So doing this we can remove the numbers that are that are greater than kth smallest integer. So now we observe that we compulsorily will have the numbers that are smaller than our kth element in our array. And second thing, we can just ignore all the numbers that are greater than our kth smallest number. That is, we can ignore 3, 5, 4 because their contribution, their absence or present won't make any difference. Now, for the kth smallest number, that is our 2, we can try to involve them or not involve them. Let's see how we can do that. Let's say we have a 2. We haven't made any decision for involving or not involving them. So let's say we got this question mark 1 question mark 1 question mark. The question mark indicates that we can either choose to have them or not have them. And at the end, we will have to make sure that the size of our palindromic array should be greater than equals to k minus 1. Because let's say at the end we only had 3 elements and we perform the operation and we have 2 elements. Now we can't choose any window of size greater than equals to 3. So the minimum size of the palindromic array could be k minus 1. So keeping that in mind, we can try to involve these question marks in our palindromic array or not. So now this array from our original array is the simplified version of the problem. Now we will need to check whether this can be made palindromic or not. Instead of operating on this, we will operate on this. Seems much easier. So we are done with removing useless data and deriving a simple problem from a current problem. So let's convert all our test cases into a simpler problem. We have our test cases as, copy them and let's try to paste them. Okay. So we have these test cases. So let's try to convert all the problems into a simpler version. So first we have 5, 4, 3, 4, 5. Here k equals to 3. So if k equals to 3, what's the kth smallest number? 1, 2, 3. 4 is the smallest kth number, so we can just remove all the 5s, and our simpler version would be having 4s. And 3 would be compulsory in our resultant palindromic array because it's smaller than the kth smallest number. Let's see for other test cases. 1, 1, 2, 1. Here we have k equals to 1, so we can just remove 2 because it's greater than the first smallest number, and we will have 3 question marks. Let's see about 2, 3, 4, 5, 3, 2. Here k equals to 6, so removing the sixth smallest number, that would be 1, 2, 3, 4, 5, 6. The numbers greater than 5, there are no numbers, so we would just have our simplified array as 2, 3, 4 question mark 3, 2. And for next test case 4, 5, 2, 4, 3, 1, we will have as k equals to 4, 1, 2, 3, 4. We can just remove this 5 and we will have 2 question mark 3, 1. Let's do for the others as well. 4, 7, 1, 2, 3, 1, 3, 4. Here k is 5, so 1, 2, 3, 4, 5. 3 is the kth smallest number, so we can just remove these values and we'll have 1, 2, question mark, 1 question mark, and 1, 2, 1, 2, 2. For 1, 2, 1, 2, 2, here k is 4, so 1, 2, 3, 4. We will have 1 question mark, 1 question mark, question mark. And for 2, 1, 2, 2, we will have k equals to 4, so we will have question mark 1 question mark. Okay, so let's see if we can make these simplified arrays as palindromic or not. We will use two pointer approach for that. So let's say our first pointer is at here and our second pointer is at the end. Keeping this in mind, we also make sure that the length of the resulting array should be greater than equals to k minus 1. Here k was 3. So we'll have to make sure the length of the palindromic array should be greater than equals to 2. So 2 question marks. Can we have this in our palindromic array? Yes, we can have that. They will match with each other. Now our pointer will shift. They will come here. 3. It is compulsorily present and it is matching to itself. So yeah, our answer is yes, we have a palindromic array. Let's try to solve for this one. We have our starting and ending point here. Can we match them? Yes, we will match them. We'll use the value at these positions, whatever that value was. I guess they were 1. We will have them 1 here. Our pointers will move here and the value is matching itself, and we can again say we have the answer as yes. Let's say this works or not. We have our starting and ending points here. These two match each other, so we'll move next. Our pointers will come here, so they match each other, so our pointers will come here. So now we can see that we have a non-matching pair. So here we can make a decision of this question mark to not have. We decided to not have this question mark. This pointer is moved here. Now comparing 4 to 4, we have a palindrome. So yeah, the answer is yes. So in this, we made a decision of not using the question mark to get a palindromic array. Now let's see here what we can do. Now we have 2 and 1. Now is there any way we can make these two equal to each other? The answer is no, because we can't skip them. There is no character that can be inserted left or right or middle or anywhere to make these two equal to each other. because they have to be present in our array as stated earlier that all the numbers smaller than the kth smallest number have to be present. So we directly print answer as no. So let's see in this example, can we make this palindromic? We have our starting and ending points here. Can we make this equal to each other? We can try to make this equal by skipping this. So we skipped this one and moved our array here. Now we can see that we have our matching indices. So yeah, that's good for us. We move forward. We have this. Can we try to make these two equal? 2 and a question mark. So we can do that by skipping this question mark and array would be here. So we skip this also to make it palindrome and it became like this. So answer should be yes, but no. We can see that for this test case the answer is no here. And the reason for that was our first condition that the size of the palindromic array should be greater than equals to k minus 1. And in this example, we can say that our k was 5. And what is the length of the array? Here the length came out to be 3, which is smaller than k minus 1, that is 4. So here the answer should be no instead of yes, even though we are able to make it palindrome, but not with the given conditions. Let's see for this. Are we able to make it palindrome? These two does not match, so we can skip this question mark. We can again skip our pointer come here. These match, we go at middle, we can take it. So our final array would be this, which is a palindrome. So answer here would be yes. And similarly for this test case, we have our pointers here, question mark match. So we can go both here and they do not match. We can try to skip this and one and one match. So our resultant would be this, which is a palindrome. So we print yes. Okay, let's try to code this solution. The problem we have t test cases n and k, which we will take input and our array. Okay, now our first step was removing the useless data. So let's try to remove that. To remove that, we'll first find the kth smallest number. So let's find the kth smallest number in the array. Let's say I have a copy of this array as sorted array. I'll just sort the array and my kth smallest would be array of k minus 1. Now I'll remove all the numbers that are greater than kth smallest number from my array and make a question mark for all the numbers that are equal to the kth smallest number, as we will make a decision whether to include them or not include them in the future. So let's say my new array would be vector of L P, and for each array value, if E is smaller than our kth smallest value, I'll just add it in the resultant array. Else, if E is equal to kth smallest number, we would just push a question mark. Let's say minus 1 is the question mark. And otherwise, for all the number, it would be skipped. So we have P as a simplified array. The P will have a form of, let's say, minus 1, -1, 2, 2, -1. This would be the simplified array. And we want to check whether this simplified array is palindrome or not. The -1 indicates the question mark as explained in the problem. So let's say we have a function is palindrome that returns whether the array P is palindromic or not. Now, to apply a two-pointer approach, we will have a starting index I equals to 0, and we will have a ending index as j equals to p dot size minus 1, while I is smaller than j. So we will compare each and every index with its counter index. So for ith index, it would be n minus ith index. That would be equals to j. So if I if p of I equals p of j, either it's question mark or let's say an integer 2 equals to 2, question mark equals to question mark, we will just include them in our resulting array because they are contributing to becoming a palindrome. So we will just I plus plus and j minus minus and continue. Okay. So now p of I is not equals to p of j. And let's say both of them are not equals to a question mark, that is both of them are not equals to -1. In that case, since we cannot skip any index now and they both index are not equal, we will just return a no because there is no way to make them a palindrome. So if p of I not equals to -1 and p of j is also not equals to -1, we can't skip them and they are not equal, so we'll just return a no. Otherwise, let's say p of I is -1, and now we have to skip that so that in future we can get a matching pair. So if we skip them, let me mark p of I equals to, let's any dummy value, let's say -2. I've marked them -2 because I have skipped them. I don't want it in my resulting array, and I'll just do a I plus plus to find a matching pair in future. Else p of j was equals to -1, and similarly we'll just do p of j equals to -2 because now I don't want this index in my resulting array, and I'll do a j minus minus. And after all this, the size of p should be greater than equals to k minus 1. So what's the size of p? Let's say c equals to 0. The size of p would be for all the elements of p if it is not skipped. If it is not skipped means e should not be equals to -2 then c plus plus. So c is the size of array and that should be greater than equals to k minus 1. So if c is greater than equals to k minus 1, I'll just return a yes. Otherwise, I'll just return a no. So let's try to run our test cases. We'll need to print the answer as well. So let's run this, and the answer is not matching. And yeah. So we have calculated the kth smallest element wrong. This would be s because that would be present in our sorted array. Let's rerun this, and yeah, the answers are matching. So this was the solution for recent Codeforces Round problem D. Thank you.